application, what we are seeing is a hospital van that is moving between 3 points, which is patient one, the second point is patient two, and the third point is hospital three. So what we are actually seeing here, so this hospital van is actually trained using reinforcement learning. So we can consider it as a autonomous car that is moving between patient one, patient two, and patient three. So this application is, we can consider it as a simulated version. So for a coronavirus rescue mission, so the hospital van is taking the patient one and patient two and taking it to the hospital. So we have trained this van using reinforcement learning. So in this application, we can see that how the van is moving on the roads, and also it is taking the optimal path. So we can see that in here that the path that it is selecting is the shortest from the hospital to patient, and then patient one to patient two, and so on. So in the reinforcement learning, so inside the code, we have defined the rewards and the penalties for everything. So for example, if the cab is moving on the road, so it is getting a positive reward. And if the hospital van is moving outside the road, so we consider that part as a sand. So it is getting some penalty. So when it is not moving on the road, you can see that the speed of the van slows down, and when it is on the road, it speeds up. So whenever it is on a part which is not a road, it slows down, like we can see here. And the second thing that we have defined, that whenever it gets near to the location defined, so it gets a positive record. Also, we can see on the right side of the logs, like hospital found moving to patient. So I'll clear the log, and now we'll see. So right now it's moving to hospital. So whenever it gets to the hospital found moving to patient one. So now it is going to patient one. So currently the goal of this van is to go to the patient. As soon as it finds patient one, it goes to patient two, and now it gets to, like, it has gone to patient two. Now it's going towards the hospital. So the goal where the van has to go is also defined. So we have given the coordinates of patient one, two, and the hospital, and the cars know that what's the car location. So whenever it gets closest to the its goal, it gets a positive record. So that was the second point. And now the third point that the hospital van is trained on is so one is the location, the goal actually to which it's going. One is that it has to move on road, and the third point is whenever it would get close to any of the boundary, it would get a negative record. So this thing we have done so that the hospital van does not crosses the boundary. So that was it. So I would be uploading the source code for this application on in the YouTube description, so you can go and refer that. So here's the ai.py file in which we have defined the reinforcement learning part. So actually it is deep Q learning that is being trained for this application, and map.py is the file in which we have simulated the environment. So we have used Kivy as a framework to define the UI, and this part, as we can see, so brain is the network that is being trained. So it is requiring two parameters. One is last reward and last signal. So last signal is basically, so we can see in the application that there are three balls in front of car. So these are typically sensors for the car. So the last signal consists of five things. One is signal one, signal two, signal three. So this is the pixel density in front of car from three of the sensors, and orientation one and two is basically the angle of rotation, the what angle the car is moving on the road. So yeah, it is a list, and it is being composed in the last signal. And last reward is actually the rewards that we are giving to the car. So if car walks on sand, it gets a negative reward, and if it's not on the sand, it gets some negative reward. We can consider it as a living penalty, and whenever the distance between the goal and the car is getting less, so it is a positive record. And these are the conditions which define that it should not cross the boundaries of the application. So yeah, I think that was a quick summary of the code. So I would be uploading the code, as I already told, you can refer in the YouTube description. So yeah. That's it. So thank you.